In this video, we're going to continue our exploration of features that affect code quality when we're designing classes. And we're going to be working again with the World of Zuul project. The main concepts that we're going to be covering are coupling and responsibility-driven design. Coupling refers to the links or connections between separate units of a program, where a unit could be something like a method or a class. In this video, we're going to focus on coupling at the level of class. So if two classes depend very closely upon one another, we say they're very tightly coupled. What might make two classes dependent upon one another? Well, if changes to one class have a big impact upon the implementation of another class, that's a strong indicator of tight coupling. That's the kind of dependence that we're thinking about. In general, we're aiming for loose coupling. It has to be said that it's impossible to completely eliminate coupling between classes, because otherwise those classes couldn't interact, or the instances of those classes couldn't interact. A class diagram actually provides us with some hints about where coupling might exist. So anywhere that there's an association arrow on a class diagram tells us that one class depends upon the other class that it's linked to. So the direction of the arrow tells us that the game class is in some sense dependent upon the parser class. Game objects will be dependent upon the input that a parser object provides to it, for instance. The class diagram can't tell us the degree of coupling between these various classes, but it's simply an indicator that coupling does exist between pairs of classes. Why do we aim for loose coupling? Well, loose coupling makes it much easier to understand one class without needing to make reference to another class. That's a reflection of the independence that arises from having loose coupling. A really important factor that loose coupling gives us is that we can make changes to one class with potentially relatively little or no impact on other classes that are dependent upon it. And we'll see an example of that as part of the refactoring that we're going to do within this video. A consequence of all this is that loose coupling will tend to increase the maintainability of a program, whereas strong coupling will tend to make it harder to maintain that code. Therefore, we want to avoid tight coupling if we possibly can. There will be some circumstances in which it's simply not possible, but in general, there are features that we can make use of within a program that will allow us to reduce the degree of coupling which might otherwise exist if we didn't use them. So what we'll do is we'll explore this topic between just two of the classes of the Zuul project, but those two classes nicely illustrate the impact of tight coupling and ways in which we can loosen coupling in order to increase maintainability. The classes that we're going to focus on are the room class and the game class. You'll probably recall that when we explored the game class during a previous video, we noted that all of its instance fields were declared as being public. In other words, there was no encapsulation within the class, and we raised the question as to why that might be. Was there something about the nature of the game that required these fields to be public, or was it simply that the writer of this class had no concerns about encapsulation, perhaps didn't even know about encapsulation and its importance in terms of reducing coupling? There appeared to be nothing within our previous exploration of the Zuul program that necessitated having these fields as being public. So let's try and impose encapsulation upon this class definition. Let's try and make these fields private and see how that affects other classes and whether that actually leads to an improvement in the overall quality of the program. We'll do it in relatively small steps. We'll start with the description field here, and we'll make that to be private. We clearly now need to recompile the game class. In fact, what we see on the diagram is one indicator of coupling. the environment recognizes that because we've made a change to the room class, we've potentially broken or had some sort of effect upon the source code of the game class. So command and parser and command words are not associated with the room class, so they remain unaffected, but we're now required to recompile the game class in case the change we've made to the room class has broken something inside the game class. So let's compile, and actually happily we find that there are no compilation errors. So there's no obvious reason why that description field was defined as being public. And what we see is that there was already an accessor method written for that field. And in fact, the game class was already making use of that. That's now in the print location info method that we wrote in a previous video. So here, where we want the description from the room, we actually call the accessor method. So in this case, we weren't directly accessing the description field, as would have been permitted by the fact that it was previously public. So everything compiles fine. We've made no significant change to the program overall, so we're not going to run it and test it to make sure it's okay. So buoyed with that success, let's see what happens now if we change the visibility of these 4 instance variables. We're going to change them all at the same time because we probably don't gain any benefits from going step by step here. Any knock-on effects that we might have in changing one of these to be private are probably going to have to be rippled through to the other fields as well. So we'll do them all in one go. We'll change all of those public visibilities to be private. Now we've compiled, and clearly there's no knock-on effect within the room class. Once again, we have to recompile the game class, which we will do. And in fact, this time we haven't got away with it. We are going to have to make changes to the game class in order to reflect the encapsulation that we've introduced into the room class. Down here, we've got an indication that there are at least 8 errors within the source file. Let's explore what those errors are. The compiler's error message is clear. North exit has private access in room. Well, we know that now because that's exactly what we changed. So we can no longer directly access that field. It's private, therefore only accessible internally within the room class. So what we would normally do when we wish to gain access to an instance variable defined inside a class is to provide an accessor method inside the room class in order to gain access to this. So that's exactly what we're going to do. That's something that's currently absent from the room class. So we're going to define an accessor method for the various exits. Now, at this point, we need to make a decision. Do we want to provide 4 separate accessor methods, one for the north, one for the east, one for the south, and one for the west? Or do we want to provide a single method that takes a parameter indicating which exit we're particularly interested in, and therefore we'll have one method with a parameter? If we think about some of the reasons why we're introducing these refactoring ideas, we'll appreciate that if we were to have a separate method for the individual exits, when we add each new direction, we would have to add an additional method into the room class. And that doesn't seem like a terribly good idea. That's beginning to sound quite a lot like code duplication, because each of those methods will be identical aside from its name and the field that's being returned. So we're probably going to be better off to define a single method inside the room class that takes a parameter indicating the direction we're interested in, and then select the specific field that relates to that parameter to return to the caller. So let's take that approach. We want to introduce an access method into the room class, and that's going to return a room object, one of the exits, and we're going to call it getExit. It's going to take a parameter, which is the direction we're interested in having the exit for, and for the time being, we'll leave the body of that method empty because we need to decide the best way of providing that functionality. But let's write the method comment, return the room in the given direction. Now we need to recognize that not all directions will have associated rooms. So let's qualify that and say return the room, if any, in the given direction, and then complete the documentation, return the room in the given direction, or null if there isn't one. So let's go back to the game class. Effectively, what we want to say is we want to set next room to be the result of calling that getExit method on the current room, and we want to pass as a parameter the direction in which we're interested in going. So we can set the value of next room to be the result of calling the getExit method, passing the direction, and we're calling that on the current room. And that call is going to completely replace all of that text. So that's where we want to end up once we've implemented the getExit method. Let's go back to the getExit method and decide how we're going to fulfill the requirements of returning the appropriate exit based upon the direction string. Well, in fact, the text that we just cut from the game class is doing exactly the kind of thing that we're really interested in doing here. So we want to say, well, if the direction is north, then what we're wanting to return is north exit, but it's the north exit of the room object on which this method has been called. So we don't need a reference to current room because the method is executing within the room whose exits we're interested in. So we can remove all of these references to current room. We can define a local variable in here called next room, which we're going to initialize to null, and then at the end of the method we're going to return next room. So here's a process of checking the value of the parameter. If it's one of these directions, we want to return the setting of the associated instance variable by assigning to next room, and then at the end of the method returning next room. So let's compile, make sure that's okay. Let's now go back to the game and see whether the change that we've made satisfies the compiler. Have we removed all of the direct accesses to those instance variables that are now private? No, we haven't, because we see there's another section of code here that again is making direct reference to those fields. But in fact, what we're seeing here is the opportunity to reuse that getExit method from the room class. So all of these tests are saying, get me the north exit value, and if it's not null, then I want to print north. Get me the east exit. If it's not null, I want to print east, and so on. So we can replace all of these here with calls to getExit, passing the appropriate string for the direction that we're interested in at that point. And we can do that repeatedly in all of these places. And then make sure that we change the direction strings appropriately in each case. And now when we check, it compiles. The changes that we've made are so significant that really we ought to make sure that we haven't broken anything. So let's run the game. Let's call play. We're getting the location string printed out, so the description of where we currently are, and we're getting listed the exits. Let's make sure that when we go to another room, Everything works okay, we'll go east. We're back in the lecture theatre with exits west. So we don't appear to have broken anything, but we have now significantly reduced the degree of coupling between the game class and the room class, because the game class is interacting with the room class via its accessor method and has no detailed knowledge of the names of these individual fields here, or even how the room class has chosen to internally represent the way in which it models connections to other rooms. So in fact, one step we can make, and we'll consider that in a moment, is whether this is the most appropriate way to list all the various connections from one room to its neighbours. If we were to add further exit directions like up and down, we might even choose other compass points like northeast and southwest and so on. Is it really appropriate to simply list multiple new fields here and then continually add yet another if statement to the getExit method? Or is there an alternative structure that we consider for the internal implementation of the room class? Now, supposing that we can find an alternative internal structure, will that have any impact upon the game class? And the answer is no, it won't, because the game class is accessing the connection information for each individual room through a method call to the current room object, and it's entirely the responsibility of the room class for how that functionality is implemented. So we could have whatever internal structure we like within the room class, and we could change it around as much as we like, and that would have no impact upon the implementation of the game class, because it's all being accessed via method calls between the two classes. So we've significantly reduced the coupling, or loosened the coupling between the game class and the room class, because we're now in a position to make significant changes to the room class and have no impact upon the game class. And that's a big win. So what we've seen is that encapsulation supports loose coupling, because those private elements cannot be referenced from outside the class, and that's reducing the impact of any internal changes that we might choose to make on the room class. And we'll see some of those changes that we might choose to make in a moment. Another factor that reduces coupling is what we might call responsibility-driven design. That supports loose coupling. So the principle of responsibility-driven design is that each class should be responsible for maintaining its own data and providing functionality associated with that data. So whenever we are thinking about where should a new method be implemented, which particular class, should it be in the class that makes use of the data, or should it be in the class that manages and has responsibility for the data? The answer most of the time is going to be it should be in the class that has and maintains responsibility for the data, rather than the other way around. A class that owns the data should be responsible for processing it. And this is another factor that leads to low coupling. So let's return to the game and the room classes and see that principle in action. One of the things we notice about the print location info method is that it's in effect a series of requests to a room object to provide data, and then some formatting of that data in order to present to the game player. So there's a lot of access of internal data from room objects and manipulation of that data. And one of the things that it reveals is an element of coupling between the game class and the room class, because the game class has to know all of the possible directions that are potentially available for navigation between rooms. And really that's the kind of information that's more properly the responsibility of the room class rather than the game class. It would be nice if we could decouple the game and the room even further by placing responsibility for knowledge of all the available directions purely in the room class, and any questions a game object might have about the potential directions or exit directions from a room are passed to the room object to respond to. So we'd really like to move this particular method from the game class into the room class. Now we're not going to do exactly that. We're actually going to leave the print location info method inside the game class, but we're going to provide the equivalent functionality that's available inside the body of the method inside the room class. So what we want to provide in the room class is a method that returns the room's description and information about all the possible exits from the current room. So we'll write a method here called getLongDescription. It's not going to take any parameters, and it's going to return a string. And what we will have the game class's print location info method do is invoke that method to get hold of a string that it can then print to the user. So we want to print out to the user the result of calling currentroom.getLongDescription. And we're going to transfer all of this highly room dependent text to where it belongs inside the room class. Once again, we don't need references to current room because now this method is being called on the room that we're interested in. So for simplicity's sake, we can simply remove all of these references to current room, and these calls simply become internal method calls. So we'll put a comment up here, return a detailed description of the current room and its exits. So we no longer want to print this information out, we actually want to build up a string progressively. For that, we're going to make use of a string builder. And instead of printing, we will call the append method on the builder. That's compiled. And we've compiled down here as well. What we've illustrated here is an aspect of responsibility-driven design. We've placed in the room class responsibility for formatting detailed information about the way that exits are organized, specifically all of the available possible exit directions. And once again, if we think about adding new directions, in order to add directions like up and down, we simply need to add another couple of if statements and append the appropriate words onto the text that's being built up. So once again, we've added a degree of decoupling between game and room and made it easier to make later changes while having minimal impact upon the game class when we make changes to the room class. There's one final change that we'd really like to make within this class, and that's the way in which we've represented these fields, but we'll leave that to a future video. So the effect of reducing coupling means that we've now got far more opportunity to localize the impact of changes that we want to make. And when a change is needed, as few classes as possible are affected by that change, which makes the whole change process far less complicated than it would otherwise be. To review what we've covered in this video, we've seen that coupling refers to independence between units, and we focused on classes, but that can also mean dependence upon methods as well, and other structures such as packages or modules. We've discussed that loose coupling increases maintainability because it makes it much easier to change fewer elements of a program than rippling knock-on effects of changes in one unit into other units and then potentially other units beyond that as well. And the two aspects of coupling reduction that we've seen have been introducing encapsulation and the concept of responsibility-driven design. Both of these tend to reduce the degree of coupling between units.